All right, so the last thing I wanted to talk through this week, wanted to go over in being data driven. How do we translate this into what matters for our business, um, and bring all these technologies together. The agenda for this conversation, and I'm going to go through a lot of information. I'm going to make the charts available so you can kind of read through them on your own, because I'm going to have to go quick on this. I don't want to sit you guys sit here and listen to me forever. But we need to understand analysis and analytics to understand what big data actually means. Some of the key technologies that underpin all that. We already talked about connectivity and how we kind of got here. We're going to spend some time talking about data warehousing, and then search itself as a technology, and then social media. So bringing it all sort of around to the end result of really tying your business to your customer from an IT perspective, really tying your technology to your user as closely as possible. Everything hinges on this decision making process, which is really true for how we make decisions in general, and then how we structure the decision making architecture needs to follow how we make decisions in general. So whether this was developed actually through analysis from the U.S. Air Force on this whole loop of how we make decisions. It's called the OODA loop, OODA, Observe, Orient, Decide, Act. And really, what it really talks about is the first thing we ever do when we make decisions, we observe our environment, we orient ourselves to that environment, understand what's going on, make a decision about what we're going to do, and then we act on it. And then as soon as you do that, you're immediately back in that loop doing it again. From a data perspective, we can think about that as a collection, analysis, recommendations, and then actions. So that's what we want to do from a business perspective. I got some examples over there. It's all the same thing. It's this OODA loop. How do we process that? The Internet of Things, as we talked about in the connectivity presentation, brings all that data in. So now in that OODA loop, where we're observing, we have a lot more to observe, and we have a lot more that we can orient our decisions around. All the immediacy of that data and the AI that we can develop to speed those decisions and make that OODA loop spin faster and faster. The point behind making it go faster is that if you can make those decisions faster than your competitor, you're going to be able to move faster. You're going to be able to be more effective than them, and you're probably more cost effective and at least faster to market. So businesses have always used analysts, and they use this technique. Insurance companies, they're financial analysts, they're marketing analysts, but the democratization of data and the ability through the Internet of Things to put data science behind every business and to put that into our IT systems everywhere makes all of us analysts. So now we all can start looking at data and trying to intuit, to mine information, and to make better decisions based on that. So lots of different types of analyses that you can do based on the data. Statistics, data and text mining, model management, so understanding, creating models, and then seeing those models actually fit the data, forecasting what's going to happen based on all the data that we have from the past, and then econometrics that really look at how people make decisions, right, among scarce resources, and then optimize those. All of those are AI techniques then that you can build on top of the data that you get in those first four to really make better decisions going forward. All of this relies, of course, on having decent data. So that connectivity and the standards that allow you to get data safely and effectively are key. Then there's data cleansing and enrichment. So a lot of times the data that you get isn't necessarily right, but there are ways that we can figure out what was actually intended. So a lot of AI goes into that kind of thing. Synchronizing data. So if I have a big pile of sales data and I have a big pile of location data, I don't know, necessarily how to synchronize all that. There's date time stamps, there's other kinds of things. There's methodologies to do that. You have to make your data set have integrity. It's got to be synchronized, right? So we know when each of these things happened. Migrating from one format to another, federating data, similar to synchronization, but maybe you have to federate around people or around communities or around certain customer patterns. And then master data management means when we get all that together, how are we managing it continuously? So there's only one copy, and it's the master copy, and everyone else isn't coming and changing things. Data inspection is key to that, and then that ensures that you have that data quality so you can make good, intelligent decisions based on that. Intelligence reporting is the easiest stuff to come off of this, right? There's human capital intelligence, financial management, strategy intelligence, the ability to do query and analysis across that data, integrated analytics. All of these feed what we understand, so the knowledge that we can get about our environment based on the reporting and the intelligence that we get from that data. That analysis though, requires people to actually think through it, and it's not flawless, okay? There's no system that's going to be flawed. It requires an understanding of our environment. And I put this example up um, to talk about in the late 90s, early 2000s, when Airbus and their Boeing, the duopoly of giant airframe delivers, were looking at what they should go invest billions of dollars in. They looked at the same data from passengers. They looked at how do you make decisions about investment, and they came up with very different interpretations. In this case, the Boeing interpretation was to build a fuel-efficient plane. Airbus interpretation was to build a very large one that could manage these hubs. Boeing was correct in that particular case. They made the right decisions based on their understanding of the environment, not just on the data that came through. When they went to re-engine smaller planes a decade later, again, same access to data, possibly the same results, they came out with different conclusions in terms of when. So in that time, it was Airbus that re-engined their aircraft a little bit sooner. You can have the same analysis and the same technologies, but you've got to have some understanding of the business, of the function, of the strategy that you're trying to do in order to make it effective. So data management, let's talk about this for a minute. I always struggle with this with the state because, I have to pay my license and registration and fill out a bunch of paperwork. And they always ask me if I paid my property taxes. But they're the government. They know all that. So all the data's there. It's just, it's not integrated, right? They know all this stuff about me, but they still ask me to deliver this paperwork. That's an example of inefficient management. What we need to do to be competitive is to manage our data and have access to this in a very effective and logical way. You have to deal with some issues that we talked about, obviously, in our ethics week, right? Institutional ownership, stewardship of data, privacy rights, are going to always be balanced against the ubiquity of the data, making it available. Plus, you've also got to worry about the fact that technology is great, but not yet all powerful. You are still limited in storage. The more that we want to get, the more that we want to store, and it does run up against some costs associated with storage. So, and then transfer rates and translation rates, they still have to go through the computers every time you want to get something translated or the data actually formatted in a direction. So there's still some limitations and resources that we have to go through and work through to be able to get after all the data that we want. But at the end of the day, you want to get to that analysis. All those good decisions are going to be based on that data. Understanding data is really understanding your environment. Even when you say intuition, what you're really trying to do is build a business, a systemic intuition that it knows just internalized all this data and what those relationships are. Successful companies are going to rely on it. It's a foundation of all this information. So then what do we do from an IT perspective? We got to have data management systems that can support this. The business is going to run on your OLTP system. So your book goes into all these different types of systems. I'm not going to spend a bunch of time on it in the presentation that's in our reading for this week. But that's what the business runs on. It manages all your sort of volatile transaction data. And those are the big systems that are constantly generating and returning, making sales and executing on those sales and doing stuff with suppliers. Typically, that's relational databases because it has to be fast, it's efficient, it has to be correct, and it has to process quickly. It's not optimized for online analytics processing. Your data warehouses are optimized for that. So think about what you need to do when you're doing a big data search, questions about broad topics, as opposed to getting a credit card number and executing on it. That's the difference between your OLTP and your OLAP. Okay, so then OLAP, let's talk about that a minute. What is this big data? Definition, extremely large data sets that can be analyzed computationally to reveal patterns, trends, and associations. Okay, so we try to learn relationships and learn from big data. We're not executing on big data. That's for your OLTP. This is different from small data, medium data, where people sometimes bring up those topics about key things, but really you get a lot of that intuition from what you learn about big data. Big data is everything that you learn as you're a child growing up, taking in all the sensory input. You're building an intuition based on that. You're building an understanding of relationships. It emerges from the discussions of available data sets that are so large that they can't be effectively put into a database, right? So we need big data processing techniques in order to be able to process those. Unstructured data types, multiple databases. The only way you can deal with big data is to take it as it comes. So we need different technologies to do that. So why has it become prevalent now? We've got a number of technology opportunities that have come up in the last few years. Number of changes, increased usage of the internet, right? So now we can get to a lot of this data. Technology and bandwidth allocation penetration makes cloud storage and usage available for companies and home users. So now, since all the clouds are out there and available to us, we can start doing data stuff ourselves. Significant availability of storage. Storage costs have gone tremendously down. You can get terabytes of information, terabyte drives I've got up there on the right for nothing, right? This was unheard of 20 years ago. And then new tools and programming languages that have been built to look at all this unstructured data, and then multi-core processors to basically fan out and take the processing within a computer and fan it out over multiple cores, so you can look at broad data sets at the same time, simultaneously get a bunch of different searches going, and then return you something that makes sense. All of those have made the industry of big data actually viable to start looking at now. How do you operate on it? It's not structured. You have to have an index process. You got to take multiple passes on it. You got to tag the information so you can come back another time and look at what makes sense based on the question that I'm asking. All of this requires you to actually have more storage than just the data itself. So it's big enough, and now to actually process effectively, you need more storage to copy it and to tag it and do all those things. When should you use it? Basically, huge amounts of data that can't fit or be managed with an SQL database is what you should use for big data. Then we should use the big data technologies. Again, if you have a need to quickly bring different data sets into the store, you have no time to normalize everything into a database, then you use these techniques, tagging, store and forward operations, translators, those kinds of things. You shouldn't use it for rapid answers, anything like a credit card sale or something like that. And it's not great for displays. You can't have a picture of the operation that someone's working on and have it tied to a big data set. It's like doing a search and waiting for the search every time to come back. That's not what it's there for. There's three main levels of analytics that we want to go for. One is descriptive, like we talked about, getting that information out there and being able to understand it. Predictive is, okay, now I want to build an intuition, build rule sets and algorithms. Prognostics, then we take it to the machine learning, where the machine itself learns and automatically does some of those predictions into a regular process. There's different ways you can gather the data to do that, right? So there's active means to gather: surveys, questionnaires, data. People enter their stuff about cookies, tokens, those kinds of things. The person you're operating on is aware of what's going on. There's also passive. A lot of times there's unintentionally given data mining, observation, that people may not realize what's going on. So those are two different ways to do it, and obviously we have to be very careful about how we're collecting it. New rules have forced a lot of collection companies to say, look, I'm going to collect data on you through your computer. You have to accept that that's the way I'm going to do it. What other kind of things can get? Sales info, purchase patterns, cookies, and those kinds of things can track all of this. Malware also tracks all of this. So again, we need to be very careful about that. Activity monitoring is generally inexpensive. These kinds of unintentional collections, like sales summaries, zip codes that your customers are coming from, they can be keys into other databases, and then you can use this to actually translate across different data sets and understand where you're coming from. I won't go into the 4 V's, but understand, basically when you're talking about analytics, these are the 4 characteristics that you really need to understand and have to build your considerations around. The variety of the sources, how much you've got, how fast you can get it, is it relevant, and then the veracity. Is it real? Is it good data, or is it problematic? And it is possible to get too much. So anything you can imagine being collected can be collected. But there's a limit to how fast you can build those relationships. We talked about the hardware still has limitations. There's a limit to how fast the computers can operate and maintain and build those relationships. Thus, you have a lot of data collected, but you have to be able to decide what sets am I actually going to look at to try to get at something useful. Here's a restaurant example like I put up there. Small business, right? Most good restaurants do use a customer management system. They're going to make a reservation. You're going to show them all the things on the left there. They're going to understand as you go there what your demographics were, the size of the bill, how you paid, the opinion of the service staff, the size of your party. They're going to build an understanding about you. They'll send direct mail to you, right? They'll be able to work with you. If you're not a good customer, maybe they don't have an open table next time. All of that stuff can be fed into how they most effectively run their business. Other commercial programs operate the same way. Think of your frequent flyers, your hotel programs, your car rentals, Amazon retailers. All of these understand, learn about you, and then develop the relationship based on that. Search technology, the last thing, is the same kind of thing. So search technologies are core to business, not just for humans, not just for just customers sitting out there doing search, but you as a business. You use this technology at an enterprise level to find information within your organization. You have recommendation